Hey guys, welcome back to another episode of Simuleos. Today is going to be an absolutely fantastic day. One second, let me go ahead and put on this shirt instead of the one that I'm wearing. Not that it really matters, but hey, kind of like to wear collared shirts on stream just because, I don't know, I always like wearing collared shirts. Anyway, today's going to be an absolutely fantastic day, probably because we're actually going to get stuff done, I think. I mean, we kind of sort of get stuff done every day. It's just, sometimes it takes a little bit longer than I expected. So, as always, we're going to go ahead and start by opening up Zernal and going from there. So, Zernal. Okay, so what is it we need to do? Well, we need to talk about stuff. I'm going to try to do this a little bit better than the last time. So, if we have a box. Again, I'm really bad at drawing boxes, guys. We have a box. There's our box. Not so bad. Here's the idea. Let's imagine we have a single particle in this box, somewhere around here. Maybe another particle here, and let's say 1, 2, 3, 4 particles here. Okay? What we want to do is describe the position of all of these particles with a tree. We can do this with something known as a quad tree. So what we'll do is we'll first start by drawing a single line down here and another line across here to create 4 different nodes or additional boxes, right? And these nodes are, let's say, not only leaves on the tree, but for the most part, I'm just going to go ahead and say that this is an external node. Oh, that wasn't what I wanted. This is an external node. External. 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 But this one right here is an internal node. So what we've just done is the following. We've described a tree that was originally a single point, which was the entire box, as 4 separate points. And one of them needs to be split into 4 points one more time. So we do that like so. One second, let me try that one again. Here. And there. And then after that, let me just scroll down just a little bit. After that, now it's an external node, because now all of the particles have exactly one node that they're within. So just to kind of clarify here, let's kind of draw these dots here. 1, 2, 3, 4, 5, 6, 7. Where red are external nodes. There we go. Okay. Now, the reason this is important is because we now have a way to find all of the particles without necessarily traversing real space. So this means that if I want to find, let's say, the interaction between this particle here and this particle here, let's do it in, I don't know, let's do it in blue. This particle here and this particle here. I can do that simply by going across the tree. However, let's say that this particle here and all of these particles here are super duper far away. Well, because we have them described as a tree, we don't necessarily have to check each individual node to see how they interact. Instead, what we can do is we can go and check this internal node here. Sorry, I pointed to the wrong thing. This internal node here. Which means that we can kind of describe each of these particles, all 4 of these particles, as one large particle to deal with. And that's kind of why we want to do this particular method, because it allows, hey iCare, it allows for us to more easily describe the dynamics of incredibly large systems. And that's kind of what we're going to be moving to. We're moving to what's known as an n-body simulator. Now again, this is super close to the molecular dynamics. That we did before. The difference is that we are here able to do an arbitrary number of particles. By that I mean we can technically do as many as we want, but we're still kind of limited, right? So before, if we had to talk about the interaction between one particle and all of the other particles, you know, it would scale as n squared. Here, it scales as n log n, so it's kind of useful. Okay, that's kind of what we're moving towards. what have we done so far? Well, so far we have created what's known as an octree. An octree. One second. An octree is, well, the three-dimensional equivalent of a quad tree. So we've done basically the quad tree twice because we split it this way and this way to create the quad tree, and then this way again to create the octree. Now this has been created, but we don't know exactly if it's correct or not. So one thing that we have to do is visualize this. For today, we will be using NuPlot. We can change this later, but for now, NuPlot should be okay. Okay, so now let me think. What else do we have here? Next thing we need to do is work with the internals a little bit. Just to make it a little bit prettier on the inside. It kind of looks ugly right now. And then finally, after that, we also need to implement the depth first search, which shouldn't take so long, for the octree, which is just a matter of searching through the tree to find the appropriate particles. Or, yeah, to find, well, just about anything. So the depth first search shouldn't take so long. So these are the things I want to get done today, and we'll see how far we get. If we get further, we'll kind of start talking about the next thing, but I don't want to actually jump into it until tomorrow. So we'll see how far we get. Okay, so I'm going to go ahead and put up my pen, get a quick sip of water, and then we can go ahead and get started. There isn't so much to talk about. There's just so much to talk about with this one. Honestly, it seems pretty straightforward. And I'm quite happy with how far we're progressing. We're moving quite quickly through this. So I might use this simulation to kind of learn some other things. Like I said before, a lot of stuff with 3D visualization. The only thing I've ever used is Blender, and I don't know if Blender will do well with millions of particles. The other thing is parallelization. Again, for some reason I've completely forgot everything I used to know about MPI, so I need to kind of remember that. Different things like that I think would be useful to go into. And I'm letting you know today, guys, that I think I'm going to be taking this weekend off too, because even though I'm somewhat prepared for this simulation, I'm not as prepared as I would like to be. So I'd like to take a little bit more time to prepare this weekend. So that means today's Thursday, tomorrow is Friday, but Saturday and Sunday I will be taking off, and then I'll come back on Monday again. Well, I kind of came in on Tuesday today, but that's okay. That way I have some time to do some preparations on my own, and we can go from there. Because again, the way I see it, the more prepared I am for these episodes, the better they'll end up being. Now, that said, there is some fun, I suppose, in kind of doing it live and learning how to do it live, and I like that. But, again, that doesn't mean I should skimp out on, doing things beforehand. Every once in a while, you guys come up with fantastic ideas, and that's great. I love it when you guys come up with great ideas. Because those are kind of the lifeblood of the channel in a way. Okay, so what are we going to do then? Let's go ahead and cd into the appropriate directory, which is going to be Barnes Hut. Okay, cd into projects, Simuleos, and of course, Barnes Hut. Hey, an NG, what's up? Oh, that was an N. Barnes Hut. Again, I'm going to get a quick sip of water, and then we'll go ahead and get started. Today should be a good day, I think. Okay, so where are we? Let's go into this file right here, barneshut.cpp. Now again, we don't have a makefile yet. We can make a makefile in a bit. First thing we need to do is separate the particle struct and have everything inside of it. So here's the thing, I was thinking about this last night. Center mass has everything we need. Position, mass. The only thing it doesn't have is radius. However, I am strongly thinking here that if we're going to combine everything together into a center of mass, it should probably act exactly like a particle. So what I want to do is change the struct for center of mass into particle and do everything we need for this first note there. And I think we'll have... I have an example of my fork on Simuleos. Oh, my bad, I did not check that yet. So let me go over here to Simuleos. Let me see. What do I want? Let me go to Simuleos here, and then can we check forks? Yeah, here they are, forks. Okay, wait. Maybe I can't. I spent my afternoon watching live streams of Geometrical Optics. May or may not get haunted by lenses tonight. Oh, well, I'm glad that you enjoy them. Again, these live streams are, I always put them up on YouTube because every once in a while people really like watching them afterwards. But yeah, I'm glad you enjoyed them. We basically do everything kind of live, so it's one of those things that every once in a while it will, it's a little bit cringy, but you know, we get there. So let's see, where are we going? I'm trying to find Gustorn. 1 second. Let me just go to pull requests. Go to Gustorn. I want to find his profile. Shoot. 1 second. I have to find fork somewhere. Here's a fork. No, I don't want to fork the repository. I want to do this. And find who's forking it. Members? Ah, here we are. Gustorn Simuleos. That's what I want. Okay, so then we want... Here it is. And let me see. So the latest one is separate vector and particle structs. Let's see. Structs, constant, whatever. Yeah, sure, constants. Doesn't matter here. So we have box threshold 1, particle mass 1. Fair enough. Yeah. Let's see. Struct position, struct particle, vector position, double mass. Yeah, and like what I was saying here, I'm not sure here. So you do this explicit call here. Explicit particle, vector p mass, particle mass. I don't actually know what the explicit keyword does. I've never actually run across that keyword in C++ before. Of course, I'm sure it's very standard. It's just not something I've seen. Yes, so what I'm thinking about doing is just combining the particle and center and mass structs, just to make it a little bit easier to work with. Now, let me see, what do we have here? First, we allocate a list of particles. Oh, I see. There are some big changes here. And then you just read in the vector.h file? That's fair enough. Okay. I see what you did. And let me see. Auto ampersand child position. Current child, return particles. Particles. You need the explicit so that one parameter constructions aren't formed from aren't used for implicit conversions. Yeah, fair enough. Okay, printf, auto root, new particles. Autos, sure. Center mass, debug print options. Okay, so these seem like pretty hefty changes. However, feel free to submit them, and I can kind of work with them one by one if needed. Let me see. I guess I could just grab this file and change my own file. But there are definitely some good things in here that I want to work with. Let me see. The vector.h. That's the one that I'm kind of like, iffy on. Okay. So let's go over here. And let me see. So, I guess we can do that. I mean, it's not a big deal. Okay. So let me do this. Let me write and quit. Let's grab the appropriate file. So let me just cp. Over here, optics, 1 second, geometrical optics, optics visualization.h, and let's bring that over here. Let me go into optics visualization.h, and let me change this to just, let me move that too. So move optics visualization.h into, what do I want to move it into? I want to move it into, let's call it, vector.h or something like that. Yeah, sure, that'll do. Okay. You said yesterday that you liked the vectors in geometrical optics. Yeah, I know, it's fine. It's fine. I feel like it's kind of overkill here. So let me go into vec.h. Let's go over here. And yeah, we'll use it. It's probably worthwhile to use it. So let's do vec.h. Let's go over here, add in some guys there. And let's change the purpose. Okay. So the purpose here is to hold all vector operations for Barnes Hut. Okay, let's go down here. This is using Cairo, be careful. Nah, not using Cairo anymore. We will define this as vec.h. Okay, let's do it. Vec.h down here. Or underscore h, whatever. We don't need Cairo. Let's go ahead and remove some stuff that we don't need here. Template string, don't need any of that. Oh, wait a minute. This is where we have all the vector stuff, isn't it? Wait a minute. Is this not where we have all the vector stuff? Nope, I think I grabbed the wrong file. 1 second, let me see. What do we have here? We have vector here. I think I grabbed the wrong files. Let's cd into the appropriate directory. I think cd. Okay, fine. So let's grab this. And I'll just grab this file, which I suppose I could have done in a different way. Now we have to delete all the lines over here, which is done super easily in Vim by just typing in DG. There you go. Open, paste, done. You go up here at the top, and let me remove this additional header and write a quick note saying that notes, this file was written by Gusthorn. I feel kind of bad because I know that whenever I do this type of stuff, like, your name's like not in the commit message for this one. You know what I mean? So I don't know if maybe what I should do is find a way to do this a little bit differently. But that's okay. So let's grab this. Here, right quit. Now we need to go into VI Barnes Hut. And what I want to do is change all of the positions to vectors. So let me check. 1 second, let me go over here to where were we? Vec.h. And let's see, struct vect. Yeah, that's exactly what I want here. So let's go over here and just kind of change all the positions to vex, because I think everything else is the same here. Yeah, so we can pretty much remove the position struct here entirely, and we can just change them all to vex. So let me go here to position. And unfortunately, I'm going to have to go through and check them kind of one by one, because I'm sure I accidentally used position, yeah, for other things. However, let's see what happens. What's the worst that could happen, right? Change all the positions to vectors. G. Good, okay. So this changed p position into p vec, but I think that's the only other keyword that I used that used position. So we go ahead and right quit here. Right and quit here. Now we have to make a makefile. And again, as you guys know, I'm awful with makefiles. So let's go here to makefile. Okay. So let's see. What do we need for a makefile? I know for a fact we need CSX flags. Screw it. I'm not doing this from scratch. Let me go into optics visualization. And let's grab that makefile. Geometrical optics. Then we go into the makefile. Here we are. Okay. So let's do this. dd icxx equals g++ for mine. You can of course use Clang. CXX flags. We're going to use the same flags as the last one, which are going to be C++, std equals C++11. G for debugging, which I suppose we can take off in the end. Wall, March native. And actually, guys, I don't remember what March equals native does. I just remember I was told to put it in there. F OpenMP. What do we have here? You can easily extend vector addition to center of mass 2. So the mass calculation 2 is automatic. Yeah, in fact, we're going to be, yeah, we'll be doing that in a kind of, sort of, in a bit. We'll see how far we get. If you have specific ideas, let me know, and I can totally implement those as we go along. Because I'll be honest, the more C++y I get, the less comfortable I am with the code. So it ends up being where it's usually my fault that we lag behind in terms of the latest features. Am I missing something? C++11G, wall, March, native, F OpenMP, O2, and then we go. I really just like non-mathematical vectors, operations on vectors. I see. So let's do FL TO. Okay. I'm not going to grab this guy, but I will go down here. We don't need Cairo flags, but we do need bins. We're going to say bins are going to be equal to, not geometrical in this case, we're going to say Barnes hut. Did I really not lowercase the h? I have to have lowercase the h. Or uppercase the h. Oh my gosh, what am I doing? Hut. There we go. Right quit. Let me do an ls. I did a very bad job of naming this. Let me move Barnes hut into just lowercase Barnes hut. Oh, dang it. Move. Move. Where's the M? Move Barnes hut to barneshut.cpp. Hey, so one thing I want to point out. It's useless with one CPP. Well, I mean, we'll use multiple CPPs probably in a second. So let's go into the makefile one more time. I think it's okay to leave that there. So we'll do Barnes hut. I'm going to lowercase the b here. Lowercase the h here. Just forgive that. Now, let's see. What do I want to do? Objects. In this case, it's just going to be Barnes hut.o. Okay, next we're going to say depends. Which is going to be vec.h, which means we probably need a vec.o up here, right? I'm not sure. And then we're going to say barneshut.h. Do we have a barneshut.h? Not right now. So we'll just say vec.h. Sorry guys, I know it's kind of boring for me to rewrite a makefile, but no vec.o. Thanks, Gustorn. Again, I'm really bad with makefiles, so every time I get the chance, I like to kind of go through and rewrite it so I can kind of get the feel for it again. Okay, so here we do. Okay, fair enough. Thanks, Gustorn. Hey, Blaze Craze Gaming, what's up? I feel like it's been a while since I've seen you in the channel. Thanks for coming in, man. So let's do this. We're gonna grab all the CPP files. Oh my gosh, why? I swear, guys, I'm not usually this bad at typing, but the thing is, when I'm typing on stream, I have this microphone in the way, and it kind of changes my hand position just slightly, so it's kind of hard for me to find where my hands are on my keyboard. So then we're going to grab all the depths. 1 second, depths, here. Now what do we want? We're going to have to put in a tab, because this is, of course, a makefile. CXX. Then we do CXX flags. Frags. Flags, there we go. Cairo flags, which we don't need. Then we're going to do C, O. Then we're going to do these guys. Now, if I remember, what these guys are doing, it's okay, man. Being busy is the nature of life. And of course, there's no, you don't have to come. Yeah, it's not like we're forcing you to come, but I am glad you're here. So, my point is, don't feel bad for not being here. But definitely thanks for coming in. So, next we need to do bins down here. Okay, so see, what do we need to do here? Looks to me... Do we need this? Let's do a clean at least. Okay. rm-rf. Here we are, bins. And of course, objects. There we go. Write this. Now, let me check this. We do definitely probably need bins, because otherwise we're not making the executable. That was me being stupid when I said that initially. I apologize. Bins. Okay. Then we do objects. OBJ. Go down here. And we're going to say CXX. 1 second. I got this. CXX. Next is going to be CXX flags. Mario Man 852-bit random. What's your philosophy concerning life? Philosophy? Life? I'm not sure exactly what you mean. Like, are you asking for some standard guy's philosophy? Because I'll be honest, I'm not sure. However, I will say this. It seems as the community sort of disappeared, like KRZJ and Purposely Drifting. Yeah, so truth be told, I don't know why. But all of the old guard, and I'm calling them old guard, but they're not really, you know what I mean when I say that. Most of the old programmers are not here anymore. And it's a little bit disconcerting in a way. Not because, Not necessarily because, you know, oh, I'm the last one left. It's not like that. It's, I don't know. I made a post about it on Reddit the other day, about how, I don't know why. Well, I do feel like it's kind of Twitch's fault here for shoving the programming community into, let me see. Okay, so I did something stupid here, but that's easy to fix. There was a guy with cool music. Oh, are you talking about Imiyuka? Oh man, I loved Imiyuka's streams. They were fantastic. It was just, they were just streaming, had cool music, brought up the chat to talk to people. It was good. Yeah, Imiyuka, man, that was one good stream. Like, I don't know why, I just liked it. 1 second, let me finish talking to Blaze Craze Gaming, and then we'll go from there. I actually think Imiyuka was a female. I spoke to them I spoke to them a lot, and they definitely, well, okay, I'm not sure, but, stuff came up, and I'm pretty sure that, she was a female, but I'm not sure. Obviously, it's kind of hard to tell. Like, it's obvious that I'm a guy because I put my face up, but that's not obvious. Hey, Novelist. So, with that, my feeling is that, so I know, for example, Purposely Drifting specifically stopped streaming the moment Twitch moved us into creative, which was a move by his part. I'm not going to say it's good or bad. And let's see, I don't know much about what happened to KRZJN, but I do know that, I don't know, it's just slowly but surely been dropping off. For example, BPAF in our chat kind of stopped watching when creative happened. A lot of that kind of stuff happened. And again, I'm not specifically blaming Twitch here, but what I am saying is that there is a correlation between that and here. That's okay, man. I'm sorry about that. If you want to ask again because you missed something, let me know. Basically just, here, it's fine. Let me just do this then. Let me just do the state of programming on Twitch. Oh, misspelled that. Here. There. I made a post about this on Reddit a while ago. Just feel free to take a look at that one. Because that'll give you most of the information. I missed a couple of questions here. Do you believe in aliens or the afterlife? I don't know, honestly. Aliens, I feel like it's incredibly, how do I put it, pretentious of us to believe that aliens don't exist. At the same time, I feel like, I don't know, like we haven't seen them yet. So they're probably super far away and I won't have to worry about them. So effectively, I don't have to believe in them, I believe. Okay, and afterlife, that's a story for another day. Mario Man 852, bit random question. What's your philosophy concerning life? My philosophy concerning life is that you shouldn't waste time. You should always focus on learning and doing new things. Reason being that, how do I put this? No problem. Reason being that you can always enjoy yourself doing just about anything if you look at it in the right way. A lot of people enjoy playing video games, a lot of people enjoy watching television, but you can enjoy yourself, you know, reading books or, how do I put it? Reading academic papers even, I find quite enjoyable. So for me, I don't like wasting time. I like actually doing things at every moment in time. So that's kind of why, you know, I'm here streaming programming, because it's motivating me to do more stuff, you know? I know that's not a great philosophy, but that's just like my #1 rule is not to waste time. Okay, so let's go from here. Obviously a whole bunch of things are screwed up, and that's because we changed everything to a vector and I just ignored everything. So let's go up here and let's see. So let me first go into vec.h. Let me check what we have here. Struct vec, it says it doesn't name a type. However, it totally should name a type. Simuleos TLDR dead. I guess. I don't know. Okay, so let me see. Why does vec not name a type? Let me go into barnshut.cpp. I might have just forgotten to read vec.h in. So let me go here to barnshut.cpp. I totally did. So let's go down here and do include. 1 second, and we are going to say vec.h. Write this, go over here. And let's do a quick make. It's gonna break again for, oh, did it actually run? Huh. That's surprising. Yeah, I agree with that. However, now here's the thing, Blaze Craze Gaming. We are... How do I put this? Twitch is doing everything right at this point. Well, not everything right, but they're trying to do everything right. For example, the programming community on creative is actually pretty dang close to having our own game. Yeah, I think I've seen something like that, Gustron. It's super cool. It's like, you know, I just think we're incredibly arrogant to think that aliens don't exist. That said, how did I spell this as pervins? What was I trying to spell there? Purpose. Okay, there we go. Yeah, I agree with you there. With Blaze Craze Gaming, I agree we had a fantastic community, but we still have a fantastic community. People still come in all the time, they watch the stream, they enjoy the stream, that's the point, right? And for me, I've kind of shifted my focus. It's not all about the stream now, it's about learning things, which it always was kind of about. But to be fair, if I don't stream, I'm not as motivated to work on side projects, and I end up just focusing exclusively on work. And though my boss would probably love that, the truth is, I just get so focused that I just don't look at anything else. And I don't want that to happen. Hey, Aaron Hans, thanks for coming in. The other thing too, again, as I was saying, Twitch is doing everything they can right with creative. And by that I mean they've introduced the communities. The communities are very good. They have a programming community, works out quite well, honestly. It's almost exactly like the programming game we used to have. Then they have, you know, the ability to sift through things they said they're working on, which I don't know how long it'll take, but honestly, the biggest problem we have with the programming community on Twitch is that all of the programmers are typically game developers, right? So you go to programming, and let's say, for me personally, I don't... game development's fine to watch, but it has to be the right person. You know, they have to be, you know, doing something interesting with the code. And that doesn't typically happen with the game development streams, so you have to kind of sift through all of the other game development streams to find the programming streams you want. So... okay. And guys, let me know else's yeah, live streamer works quite well. Okay, so it seems everything runs. We have a couple warnings, but I don't think these warnings are from the vector class we just had it in. Okay, so this means we can do some things a little bit differently. Okay, good. Okay, sorry about that. Again, I don't have quality options, so I can only run I guess the bitrate that I'm currently running, which, to be fair, is not particularly how do I put this? It's not particularly bad. It, like, the bitrate's like 1,000 or something like that. Some people like stream only with bitrate of 3,000. They say any bitrate under 3,000 is just too bad for their stream. But I'll be honest, we do programming. It's not something I can really do. It might be the NSA sniffing around. Man, the NSA has just become like that one dog on the side that everyone just kicks. You know, they're like, you were nice for a while, now we don't like you anymore. Pretty sure I didn't leave any warnings, vec.h. Oh, yeah, this is all in barnshut.cpp, obviously. So, let me see. Barnes Hut, node parent, W reorder. I'm not sure what that means. Will be initialized after. Box length will be initialized after, and constructor node. Parent, let's see, when initialized here, node vector. Oh, I see what's happening. Vector location, double length, node par. Yeah, so what happened to Purposely Drifting? He deleted his channel, didn't he? He certainly doesn't stream anymore. I don't know if his channel was actually deleted. I think, it's, again, because of the creative switch. There's been a number of people who were just fed up with Twitch after that. Let me see if we can fix these warnings. Comparison between signed and unsigned integer. That should be easy enough to fix. 149. Let me see. 149. Let's see what we have here. Child vector p size box threshold. Is it really that big of a deal? No, but I guess that means we just have to read this in as a size T. There we go. Go up to divide octree. Radio Twitch. I don't know what Radio Twitch is, but I assume it is Radio Twitch. Size T. There we go. Declaration order doesn't match the initialization order in the constructor. Yeah, I figured it was something like that. Let me check what we have here. So there's the constructor, vector location, box length, parent parameter, location, length, node parameter. Let me see what we have here. Will be initialized after. It seems to me node parent. Sorry about that. Do we have to tell it? Maybe we have to tell it this. Maybe we have to go down here and say parent. Can we do it this way? Let's see what happens if we make that. Okay, so looks to me, let's see, node parent. No, okay, so it's still giving us problems. Why would it be giving us problems? Vector P, double length, mass center, mass. Parent, oh, that's because parent's up there. Dagnabbit. Let's bring this down here. And let's remove it here. Okay, let's write this, go over here. Make. There we go, got all those warnings done. Aaron Hans, purposely drifting, wasn't he the guy that used Visual Basic because he couldn't read symbols too well? I don't remember. He was just null pointer. Yeah, fair enough. Let me see, what do we have here? How do you spell null pointer? Is it like this? Oh, that wasn't right. That was definitely wrong. Oh, that was still wrong. Here we go, write this, go over here, make. Okay, that one seemed to work just fine. So we have the make file working, everything's kind of read in appropriately. Now, one thing that Gustomer did on his, but I'm not going to be doing on mine, he created two different guys for particle and stuff like that, but I think I'm just going to change all the center of masses to particles. Reason being, because, again, the center of mass is basically a particle. No, for me personally, I'm not trying to develop a game. So let's go here, let's do the following. S, we're going to say center of mass, and we're going to say particle. Okay, replace them all, and we should be set. Move parent in front of P location in the constructor. Is that just Twitch lag? Because I think move parent in front of P location. I did the opposite. I moved parent below. Does anyone else experience with no, I don't even know what that is. Right here. Let me make that. Okay, good. So it seems like everything still works okay. So now what do I need to do? What I need to do is go down here. Oh, what? I need to go down here. Artemand, just to finish answering your question, I'm not making a game. This channel is exclusively devoted to just implementing algorithms. That's what we do here. We don't do anything special. We just kind of go through and we learn new algorithms, and that's kind of the point. So right now we're learning the Barnes-Hut algorithm. It's a way to more easily do n-body simulations, something I've never done before. And it's actually super cool and fun and interesting to me. And that's kind of what we do. We just kind of go through different simulations. Sometimes they're suggested by the community. Other times I just come up with them on the fly. Like, for example, the geometrical optics one. We just kind of made that one up as we came across it. What types of algorithm? Physics, computation? Yeah, for the most part, it is computational physics. That's what we do. So the reason we do it is just because I'm a physicist. I enjoy physics. I enjoy numerics. It's all just kind of fun to me. Okay. So we can modify a lot of this stuff now that we have a vector operator. So let me see what we can do here. So let me go into vi-vec.h and let's see what we have. Man, I don't know what Qemu is. I'm not sure what it is. Sorry about that. Okay. So it looks to me like we can do this. we can just say vector p. Here's something that's rather interesting. Let me go up to, where are we defining this? We are defining child, then we have the center of mass, then we have the position, x. Good, so that's actually correct. Good. Thanks, Krams. Okay, I guess I could look at it a little bit later. Nah, it's fine, I don't know what it is. Not gonna worry about it. Okay, so what we can do here is we can say com.p divided equals mass. There we go. And then up here, we should just be able to do plus equals the position x, y, and z. So let me see, where is p? We have com.p.x plus equals open link. Thanks, I appreciate it. Is a generic and open source machine emulator and virtualizer. When used as a machine emulator, how do you pronounce it? Kemu? Can run OSS. Oh, that's actually super interesting. Made for one machine on a different machine. Oh. Well, that is actually interesting. Oh, by the way, guys, I do quantum physics, so I am a, right now I do stuff with Bose-Einstein condensation. So it's a superfluid system that's, how do I put it? It is a superfluid system that is incredibly cold, and basically you take a whole bunch of bosons, you condense them into what's known as a Bose-Einstein condensate. That's done just by cooling them down, and here they act as a superfluid. Then you just manipulate the superfluid with optics. Basically you will, we're using the evanescent field of a nearby optical fiber in order to basically create vortices and things like that. It's basically what we're doing. That's what I'm doing for my thesis. It's kind of cool. Basically, it involves a whole bunch of GPU computing and stuff, which is why I signed up for the project, because I want to learn GPU computing. Super cool, by the way. The code that I'm writing or working with right now is quite. It's good. It's fast. It uses pretty much all C, so it's good for me because I don't have to use any C++ 11 features. But I'm slowly trying to implement more and more features as we go along. I used to work on plasma physics. Optics is just kind of one of those things that I do on the side, but it is inherently interesting and useful for my research. Okay, so what do we do here? P.x plus equals P. Let me see, what do we do here? I think this is right. So let's go here and let's do the following. I want to remove this line, that line, and then go here. Okay. I only use it for basic stuff on Linux. Sorry. Oh, by the way, guys, have you guys ever heard of Scratch, the programming language Scratch? It's like a programming language for kids. Here, I'll just go ahead and give you guys the link, mit.scratch.edu. Super cool stuff. I missed the U. Okay, this is a programming language for kids. It actually has definitely motivated kids to learn programming. Like, I don't know why, but it has done a very good job of it. Every year, always has this open campus where... What are you ewing? I'm not sure what you're ewing, Aaron Hans. But yeah, so every year, always has an open campus, and we actually gather a whole bunch of kids to teach them Scratch with this programming language. Super cool. This is what happened. Basically, yesterday, we were allowed access to a whole bunch of different computers. I'm actually super excited. I have not heard of the Moral Machine. So we got access to a whole bunch of computers. We need basically about 15. And when we got the machines, turns out we have to install Linux on them. But the problem is, because of the way the wired network works at OIST, we cannot actually install Linux on them with wired networks very easily because of how they've done the security stuff. So we have to use something that uses NetCDL. The only one thing I know, distribution I know that uses NetCDL is Arch. So I'm going to have to do like 20 Arch installs, or like 10 Arch installs in a bit, without the beginner's guide, which was recently taken off the wiki. Lawrence BL, the purpose of the thesis is to make simulation software, find new phenomenon. So here's the thing. How do I put this? Currently, in order to create vortex rings in a Bose-Einstein condensate, you've got a couple of different ways to do it, but none of them are really experimentally feasible. Not not to consistently create them. And the reason it's interesting is because these allow us to fundamentally understand the dynamics of things like vortex knots and things like this. And if we could find a way to simulate vortex knots, well, that's really cool, because this is a way that we could more easily understand or have a physical system in which we can implement like knot theory and things like this. Anyway, point is, there are a whole bunch of interesting reasons to do this, being that first of all, vortex rings cannot be easily created. Second of all, it's a nice test system to work with for a number of different applications. It's just cool. I don't know. So the point is kind of in the middle there. We want to make the simulation software to find the new phenomenon. And that's kind of where we're going. Moral Machine is an MIT site that poses questions about what a self-driving car should choose to do when there's an unavoidable crash. How do I keep misspelling everything? Somehow I've been here before. Here's a link, guys, if you're interested. Have you ever heard of magneto-optical? Traps, for example, magneto-optical traps. Kind of in a way, yeah, that's kind of what it is. So the new physics is a little bit, yeah. I'll admit, it's not as new as I would like. Honestly, best case scenario, I'd love to move into working on different physics algorithms and stuff like that. That's kind of where I enjoy working. But that said, we're getting there. I don't have so many papers out, obviously, because I'm a PhD student. I only have one paper out, and I kind of feel bad about that. But, yeah. The nice thing is that a VEC is a superfluid, so it's kind of, it's an inherently ideal system to work with. Okay. Let's see here. We have vector current box length here. Let me see, how can we move this one a little bit faster? Do you know how to deal with material preparation techniques? Not really, unfortunately, Artemand. If I did, I would... I know people who probably do, and I could definitely ask that question. But material preparation techniques are like, it's such a broad thing. I don't know exactly what you mean. So for, like, what materials do you mean to prepare? And maybe it's just jargon that I don't understand. But what in particular are you asking to work with? Okay. So I have current p.x, current box length. That all seems okay. Let me go ahead and right quit here. And let's make it. Okay. Still seems to find all the particles just fine. PLD, particle location. Is that what that means? I actually don't know what PLD stands for. Sorry about that. So I probably can't help with the material preparation. No more segfault? Nah, man. No more segfault. Okay. We can probably fix a whole bunch of stuff up. And what I'm going to do is tonight, I'm going to go through and take a look at Gus Torrens' pull request. Or not pull request, but his version of the code. And we're going to fix up everything we can. It's not printing Z for... I'll change that right now. So what do we have here? Childcom.px, childcom.py. Let's go ahead and output childcom.pz. And we'll go from there. Child, pointing to center of mass, .p.z. And now we're going to do a new tab. There you go. We have it. Material characterization. Pulse layer diff. Yeah, so that's a term I've heard of, but I don't know much about it. Again, I don't do a lot of experimental work. I do pretty much just theoretical work. So, the dog is the most saved character? So I'm not sure about that. Sorry about that, Artemen. I wish I knew more, but I don't. So let me go here, write this, go over here, and let's make that. Now we're outputting Z for that one, but we have to do it again down here. 1 second. Let's just output or copy this. There. That should do it. Write this, go over here, make. Now we're outputting Z. Sounds good. Okay, so now what else do we need to do? I need to go up here. We have childcom.mass equals p.mass, which is good to have. So now every time we initialize the particles, we should probably also initialize them with a mass. So here's what we're going to do. All of these vectors that before were just vecs, we're going to change them to particles. Have you dealt with nanomagnetism and spintronics? I have heard of them. It's not something I've dealt with. You're drawing all of these things, like I mean, I'll be honest, I have just a very small subset of things that I've worked on before. On the one hand, I kind of wish I've worked on more, but that's kind of why I'm here doing these things, right? So that I can kind of say, hey, look, I'm kind of learning things on the side. So let me see, random distribution, this should return particle. There we go. Is your paper public? Can they be understood by someone with basic physics bachelor's? Yeah, actually, it's, the only paper I have out right now is the following. So, shoot, what is it? Noon states on a ring, tungsten audio gas. It's, generating noon states, shoot, something like this. You'll probably find it. No, you won't. Dagnabbit. 1 second. NJP? Noon state heralded. Non-adiabatic. Oh, I got it. Non-adiabatic generation. I got it. I remember the title now. Non-adiabatic generation of noon states in a Tonks Girardio gas. Okay, there we go. Here it is. Good. That's the only paper I have out. Feel free to try to understand it. I just now realized how much jargon is in the name. Okay, that's good. Feel free to look at it. I can talk about it if you want, but ultimately it is an applied project that, honestly, there's some people that watched this stream who had significantly more to do with this work than I did. However, I kind of pulled things together and things like that, and they, for personal reasons, didn't want to be first author on the paper. And I asked, and they just said no to it. So I was like, okay, that's fine. But yeah, the issue is, it's actually super cool. But anyway, that's beside the point. This is like research that doesn't matter. By the way, oh my gosh, why do I keep talking? I need to like do some sort of programming here, and I'm doing like no programming whatsoever. But check whether a vector, oh, a position. Position. Okay. Yeah. By the way, I need to ask you guys a question. What do you guys think about institutions that have YouTube channels? Like, for example, Fermilabs. They're really pushing their YouTube channel. Let's see. There's Fermilabs. MIT OpenCourseWare, of course, is a great idea. But I want to know your opinions. Like, let's say OIST had a YouTube channel, and we put out content specifically to attract people to the YouTube channel. Like, we put out content like, I don't know, kind of like maybe a 60 symbols type of content. Would you guys think that is a good thing, or would you think that we're kind of wasting people's time with that type of material? You know, like we'd go around OIST and we'd say, hey, look, what do you do for research? And then we'd sit them down and they'd explain their research or something like that. Would that be interesting to people? That's the question. Obviously, these are just opinions. I have no say on what OIST does. Absolutely nothing to do that. I don't know. I feel like YouTube is good for education too. I mean, look at the OpenCourseWare stuff. I mean, that stuff works quite well. Okay, so let's see at vector here. We need to change these to position. That wasn't right. Position here. And let me bring the size t box threshold down to the next line. Pop stuff poll views doesn't really help anybody, but it does actually help some people. You know. For example, the institution that I'm at, the Okinawa Institute of Science and Technology, is it is at this point new, right? And so we need to attract people to OIST, and we want to attract the right person. And if we put out the right type of video that attracts the right type of people, well, we'll get people to look at let me see. We'll get people to look at us in a different way. The only way a science channel would get views would be a small 5-minute video with a brief explanation of some topic. That might be true, but again, look at Nottingham University. They've got a whole bunch of people out there that are doing a whole bunch of different science. So you've got, like, for example, 60 symbols. See, is CGP right there? I'm not sure. But you've got 60 symbols, obviously periodic videos, a computer file, number file, a whole bunch of channels there, all doing just kind of outreach. and their outreach is via YouTube. Yeah, that's exactly what I'm thinking about, you know? And they're all from Nottingham. Most of them are from Nottingham. And so I'm thinking, you know, why not just do something similar? Except do it for, like, our research here, you know? Because I think that'd be super interesting. It's a way for, like, I don't know, it's a way for researchers to very easily give their research out to people and, I guess, have the right questions asked. So anyway, I guess the opinion here that I'm hearing from you guys is largely that it wouldn't matter. In terms of, you guys don't care so much about having institutions with YouTube channels. So that's fair enough. Way to follow or expand knowledge that some things exist. Yeah. I like Numberphile. He's cool. They don't like coding on Computerphile. That's true. They mainly talk about computer science. Dagnabbit, I'm so behind. What am I doing in my code right now? Let's change these to positions. If I can spell position correctly. Position. I can't. Every time I say position. There we go. And when their videos past 15 minutes, no one really cares. People seem to switch to other entertaining videos. Honestly, it depends, right? I mean, I watch over 50-minute videos all the time. And I don't usually have a problem with it, especially gaming videos. People tend to like over 50-minute videos, you know? So I'm not sure exactly what we need to do there. I had a blast trying to explain the Monty Hall problem in the comments for some Numberphile videos. I mean, that's the thing. There will always be people who are interesting. There are always people who are going to be interested in doing things like, for example, Gustorn, you know, and people on this channel, people actually watching right now, are probably interested in just watching people do things and learn things and things like that. I mean, I think there is an inherent interest in this kind of thing. Okay, this is gonna break in like a number of different ways when I try to run it, and I apologize for that. Let me grab this. Paste it here, add a D and a comma there, and this here. Oh my gosh. D comma, there. Remove this, remove that. Okay, I also need to remove this. Oh my gosh, what am I doing? Move this down here. Gaming videos equals entertainment, check pros or the fails. Well, I watched your optics. It wasn't anything I haven't done before, a long time ago. Yeah, fair enough. I mean, again, I apologize for that. I guess it may have been a little bit simple, but it was still something I hadn't done before. I really watch short videos on YouTube anymore. I prefer in-depth discussion podcast. Yeah, I think that's generally too. I think that people, when they get an understanding of a topic, they tend to, well, how do I put this? They tend to kind of enjoy talking about that topic, if that makes sense. Okay, let me see. All these are going to break. I'm just hoping that they don't break so badly. Change this to a particle. Particle. I could drop it to my real-time ray tracer, more complex refractive indices, etc., than normally necessary. Yeah, I mean, that's true, right? I spent a majority of my time with there just kind of making the ray tracer. Let's make this, see how it breaks. Yep, of course it's going to break in a number of different areas, but that's okay, we'll fix it. Position was not declared in the scope. One second. S position particle G. Struct particle has no member X, Y, and Z. That's fair enough. Okay. So particle has within it, let me see, everything we need to work with. So here it is. Struct particle, it has vector P inside of it. Is your ray tracer actually doing global illumination? Because if it is, that's pretty impressive. And Galaxy Simmer isn't far from something that could come around when doing games. Yeah, that's fair enough too. Again, I'm not claiming here that we're doing stuff that no one's ever done before. I'm just doing stuff that I haven't done before, and hopefully it's interesting to people too. Position was not declared in the scope. Oh, this must be after here. Let me clear a couple times and remake. And let's do make here. Sorry about that. Okay, so let's go ahead and fix everything up. Error has no member X. So all of these guys are issues with our particle here. The version I have at the moment doesn't. 15-year-old version did, but doesn't have it anymore. Could do much better nowadays. Yeah, that's fair enough. Again, you know, kind of the purpose of this channel is that we're kind of learning this stuff together. And if you've done it before, you've done it before. You know, I can't just, how do I put this? I can't not do things because they've been done before. You know, one of my old professors, he said that, let me go to 119. He said that you shouldn't do anything if it's already been done before. And I fundamentally disagree with that philosophy. I think that there is merit, no matter what you're doing, to repeating what people have done. I really want to write a new ray tracer, but I have more urgent hobby projects. Yeah, I totally understand. Again, I appreciate all the help you guys gave me with that, by the way. I'm not saying that you should do things not done before. I'm not saying that you should do things not done before. Let me see. What do we have here? 139? Here, so we want child composition. What's see here? No match operator for plus equals. Okay. Let me see. The only way to learn something properly. Yeah, I mean, yeah, I kind of agree with that. Okay, so let me check. We have struct particle has no member X. Okay, so these are all going to be in 171. I know where that is. No match for operator plus equals vec and particle. That's fair enough. That means this needs to be changed to a p.p. Okay. Now, I apologize for the notation here. We need to fix that up. All these guys need to be changed to p.p.x. Yeah, let me think. There should be a way. I need them as particles for a number of different reasons. But we could put in the vec struct. No, I should probably keep them separate. It's okay, it's okay. The worst that happens is we do this. 1 second, you? Yes, that plus one's probably not good anymore. And what do we do here? Vec.size? That's not what I want. I want to do this, child vec. Yeah, that's actually correct. Good. Okay, so let me go through and let me very quickly change all of these guys to what they should be now, which should be something like, oh, that wasn't right. .p. There we go. Have you considered dropping a mixtape? Me? No, I have not. Okay, this is pretty bad. That's pretty bad. Okay, let me go down here. Children and particle current position. Current box length times 0.25. Let's run this one more time. Write this, go over here, make. Okay, so we still have a whole bunch of errors. Did I write it? Clear a couple times. Let's try it again. Make. Let's see what we got. Okay, so let's fix all these guys up. Struct vec has no member P, 170. Yeah, I figured. Oh, that wasn't right. That was 17, 170. Let's go. Struct vec has no member P. Oh, these are already vectors. Wait, what? How are they already vectors? P.P. Oh, current is already a vector. No, it's not. If you don't already. In your occ tree, you should probably start particle stars if you don't already. I will fix that in just a second. Let me see what's happening here. Let me see. So error, struct vec has no member named P. It says current. How's it a vector? Current P.x. Oh, it's a current position. Yep. There we go. Okay, struct particle has number X. Let's go to 202. Hey, Fled from Nowhere. What's up? By the way, you told me at some point to pronounce your name Fled from Now Here. I was pretty sure. Like, I was 90% sure. However, your YouTube name was Fled from Nowhere. So now I don't know. So I might just call you Fled from now on. So I don't have to do that anymore. I apologize. So let me go here. Let me do P dot. Oh man, what's happening? Dot P is what I want. Here and here. This is awful naming convention. We need to figure out how to fix that. Okay. Fled from nowhere. Good, thanks. Okay, so let's see. Vec has no position P. Write this, go over here. Yeah, sorry about that. And then from then on, I just kind of stuck. But that's okay. So let's go here to make. Now, what's the last error? No matching function, particle, particle, double, double, double. No candidate, particle, particle. What is the issue here? In file included from C++ H. If you use the Twitch chat interface, you'd see the captions. Yeah, my bad. But that's okay, not a problem. I will keep that in mind from now on. I apologize for mispronouncing your name up to this point. Okay, let's see, what do we have here? Barnes Hut, 24.8. 24. Okay, what's the issue? Candidate, particle, particle. Struct particle. Candidate expects 0 arguments, 3 provided. Candidate, constant expression, particle, constant. Huh. Okay. They're called, I knew what you meant. But yeah, capital letters. Okay. New allocated dash H, no matching function, for call, particle, particle, double. 1 second. Where are we? Constant expression, particle, particle. What is the issue? Okay. You should add a constructor, see my code. Oh, do you have a constructor? Oh, you probably do. Yeah, of course you do. So let's go here. Would the constructor fix the issue? I feel like... okay, one second. So you say particle here. Sorry for the on, guys. Okay, so let's grab that. Go down here. Paste it there. Remove these spaces. Let's see. Does that actually fix the error? No, the error is still there. I don't think the constructor is the issue here. Well, here, let's remove explicit just to be as clear as we can here. So, write this, go over here, make. Yeah. Candidate expects 2 arguments, 3 provided. Candidate, particle, particle, vector, double. Barnes Hut 28.5. 28. Let's see, particle. P, double mass, particle, mass. Oh, first of all, I don't have... Okay, 1 second. Okay, so M is particle mass, which we don't have defined. But that's okay. Let me see. So when we define all the particles here, where's our pvec? Struct node. I know we have... Oh, down in main. Main. Let's go down here. What do we have? Main. Divide octree. Pvec. Where do we find pvec? Here it is. Create rand distribution. Create rand distribution should be here. We'll say pvec is that, and then we will say for I less than p number, pvec in place back. Let's see, what else do I want to do? Box distribution gen, box distribution gen. Oh, and then I also guess we want some sort of mass here. So we'll say, let's grab this guy, let's grab that guy. So I think that should create a, and then we want particle mass. I think that was what you said, particle mass. Something like that. Okay, let me go up to the top again. Okay, so we have vector particle, position P, mass M. Let me go ahead and write this, make that. Yeah, I figured. Particle mass is of course not defined here. Let me go into vi vec.h. And let's define particle mass over here. So where did you define it over here? Let me see. One second. You need to do vector, box gen. One second. I guess it was defined up here, wasn't it? Yeah. Why not? I will have that defined there. We go to barnsat.cpp. Let's go down here and add in define particle mass. And I'm just going to set it equal to 1 for now. We can change that later. Okay, you need to do vector box gen. Let me see. What do we have here? Vector p box gen. Let me see. Okay, fair enough. Then the following. Okay, yeah, let's check that. But obviously I need to create it first. You're right. My bad. What am I doing here? I am up here. So let's change this to a vector. There. Okay. Right, let's go over here. Make that. Error. Expect primary expression before equals. How did I do it? Define wrong. Go up here. Dag nabbit. Let me go over here. Let me check something real quick. One. I guess I'll just do it this way. Constant. Double. Right, this go over here. Let's try make. Okay. This, I'm not sure where all the errors are, so let me clear again. One second. Let me do make. Okay, so lots of errors here. Struct particle does not have any field name position. Okay, let me see. Particle position, let's go to 31. Here, position P. So this should be vector P. There. To match what we have up there. No matching function call for particle Barnes hut. Error particle com. No matching function call for particle com. Okay, so let's go ahead and clear a couple times again. Let's go over here. Let's make it. Okay, I thought that would fix it. Vector is not a direct base of particle. One second. Oh, shoot. I named position P. What? When did I change that? I don't remember changing that. Okay. Let's go here to make. Let's clear again. Sorry about all the errors, guys. Let's just fix them all and then go from there. Okay, so error, no matching function call for particle, known null pointer. Okay, fair enough. Let's go to 52. Okay, let's see, what do we have here? Node, pvec, no matching function call. Candidate particle, vec double, explicit. One second, let me see. This should just be another constructor. Candidate particle, vector double. Oh, I bet you I know what's happening. Let me see. So what are we doing here? Let me see. New node. No matching function call for particle. Let me see. P vector. Fair enough. Box length. Parent null pointer. No matching particle call for particle. Explicit particle. Wait, what? Particle vector P here. Okay, so these are two big errors. Well, three big errors. Let me see. What is no matching function call for particle here? Let me see. Parent. I gotta think here. Okay. So we have a center of mass now. How do you get your hair done when your barber speaks Japanese? Well, very interesting question. I bring in a picture of myself and I just ask them to do that. They get it right sometimes, they don't get it right sometimes. That's how it goes. Okay, one second. Node here, box length P vector. That's the position. Box length here, parent null pointer. Okay? P location box length. Let me see, particle, 54. No matching call for particle. Okay, so let's see. Function call for parent 52 and constructor for node. Huh. Why is it trying to draw a particle anyway? P vector here. Box length parent null pointer. If I just remove the parent null pointer, will that fix the issue? Not sure. Let me see. It cannot initialize center of mass. Why can't it initialize center of mass? We're not even trying to initialize center of mass, right? So there's no reason for it to initialize center of mass. Error no matching function call for particle. Are you full-time in Japan, or are you based in the US and sometimes go to Japan? No, I've been living in Japan for the past 2 years. Unfortunately, well, I guess fortunately and unfortunately, always speaks exclusively English. So I haven't really, how do I put this? I've not really learned Japanese very well at all. My Japanese is awful. I'd like it to be better, but it's really bad. I need to get better at Japanese, but I've not had the time really to learn it. So, okay, let me see. No matching function call for particle, and node. Okay, so it's still giving me trouble. I don't understand why it's even trying to initialize center of mass, because it shouldn't. Is it up there? Let me see something. One second, pointer, here. 1 second, that's a num pointer. I want null pointer. Oh, so I have to go over here and type something like... Wait. Here. Okay, 1 second. And then we'll just say... let's say vector... 1 second. You seem to have many Japanese friends around right now? No, not right now because it's 6:17 in the morning, and it'd be very weird if they were in my apartment with me. But I do know quite a few Japanese people. I mean, like, it's not like I don't know anyone from Japan. Let's see, node here. What do I want? I'm gonna do the following. They don't do Twitch very much over here. So let's do P. Vec here, like we were doing before. Should be okay. So we'll initialize it at 0, 0, and then we'll give it mass of the following. So let me see. Mass. 1 second. Of particle mass. Yeah. Something like that, maybe. Right here, go over here, make. You only have to worry about the mass. P already has a default constructor. It will be initialized to 0, 0, 0. Let me see. Let me see. You doing kinematics? Kind of. And no, not like Godzilla. Although there was a Godzilla movie that was shot in Okinawa. Let me see. Already has a default constructor. It will be initialized there. Okay, well, let me see. So let's do exclusive particle PP, vector P, vec P, mass, 1 second, double M, remove the pvec. How did you get the compiler to do that by default? Make. 1 second. Let's clear here. Yeah, you've been talking about that aimbot for a while, man. So let's go up here. Okay. Does each frame count as a time interval? We haven't gotten that far yet. Why didn't that work? 1 second, I have no idea how this works. Why is this not working? I removed this completely. It should be that the struct particle is just a very simple struct. Field com has an incomplete type. How is it incomplete? How is it incomplete? 1 second. Clear. Make error, anachronistic, old style base class initializer. Particle. I don't even know what anachronistic means. I don't understand how that works. So it should be, but it should be if I remove these guys, it should still work, right? Because you don't need an initializer. Error, no matching function call. Hmm. Yeah, I'm not sure. Not sure. Okay, so I'm just gonna, I guess, keep that in there. Oh, I didn't know that. Let me go down to mplace. Back. Let me see. Here. Box distribution, particle mass. PVEC. PVEC should be a particle. Okay, let me see. Should be the particle vector. Okay. It's a vector of particles. Sure, that's fine. Then we're saying mplace back. I see. Okay, one second. Let me think. So we're reading back. We're reading back a constructor. Definitely. You're right. You're right. Fair enough. Okay. Good. So there's some bad notation here because I just kind of screwed with things to get it to work, and it's kind of hacked together. That's kind of something I need to look at, but I might take a look at it later this weekend. mplace does construct the value. mplace constructs the value in place by calling the appropriate constructor for the arguments directly to it. Yeah, fair enough. I see that now. It's kind of obvious looking at the code. Now, what do I need to do? There's a couple of things I wanted to get done today, and we might be able to get it. Might be able to get a couple of them done. So the separate particle struct for whole mass radius and stuff like that. This guy has been playing a lot of video games in Japan. Who is this guy? Me? No, I don't play very many video games at all if you're talking about me. Sorry about that. Okay. So we have a couple of different guys that we want to write out. Let's see. We can probably do the depth first search now. It shouldn't be that big of a deal. I have a GTX 970, and I'll be honest, that was kind of a mistake on my part. I was asking my friends when I was building this computer, I was asking what I actually have 32 gigabytes of RAM, but I was asking my friend what I needed, because all I'm going to be doing is simulations, and he's like, oh, you should get a GTX 970. So I was like, okay, yeah, that sounds like a good idea. So I got my GTX 970, and yeah, that was not needed. No, I can't give you my GTX 970. I still use it every now and again to run my my research code because I need it for the GPU computing stuff. That said, I could have gotten a weaker card because our local cluster, by the way, it's fantastic if you're looking for a graduate institution with a good cluster to work on. You could definitely take a look at that. You could do better physics for video games when you finish your studies. Actually, not really. The truth is, how do I put this? The truth is, the physics that I do is not really related to gaming physics. I mean, there are some stuff there with dynamic meshing and things like that, which I want to get into, but no, it's not so related. It's not as related as people might think. Okay, so let's just go through and write a very, very quick depth first search algorithm here. Algorithm, I guess it's an algorithm. Depth first search guy, I suppose. So let's go down here. What do we need to return? A BEC game? Actually, oh gosh, you guys, there's a really cool thing out there. What is it? It's Science at Home? Is that what it is? Quantum. Okay. Quantum moves. This one. I knew what you meant, Frank. This guy right here. When we were at one of the conferences that we had at OIST. We hold a couple of conferences here, and we bring, in my opinion, pretty high-impact guys. The people who developed this game, one of them actually came to our conference and gave a talk on it. And what was so cool is he mentioned that this game actually actively improved their research. Because the truth is, we've been using all these techniques to basically move particles from one well to another well. And, you know, we have like adiabatic techniques, which allow you to transfer particles from one well to another well with 100% efficiency. But adiabatic is also really slow. So people have been trying to find shortcuts to adiabaticity, which is a big thing in the quantum field right now. However, people haven't really found the best algorithm to do this. And so someone made a game, this game, the one I just sent you guys a link to, and people were beating shortcuts to adiabaticity just by playing this game. And it's actually really cool. The fact that you can optimize a quantum system by giving it to the public and having them discover how to do it. It's like the opposite of machine learning. It's like human learning. But it's so cool. So let's just write this real quick. Oops, my bad. Here, we'll say function to perform a depth first search of Octree. Someday you could work doing a physics-based game engine as good as CryEngine. Don't give up. But see, here's the thing. I don't want to do that. My ideal career, and I've been thinking about this a lot. My ideal career is probably like a physics professor somewhere. I don't want to be in a high-impact place. I want to be just some, school in the U.S. And that's honestly what I think I'd be good at, because I know the physics decently well. I can do pretty good lectures. I'm not the best teacher, but I'm not bad. I like teaching. It's fun. And I also like, let me see. I also really like research, and being a physics professor allows me to do both research and teaching. It's like one of the perfect jobs for me. Frank, I'm sorry. My linear algebra skills are bad. I admit that. I can get better with time. I mean, I know enough to do, all the physics stuff that I had to do up to this point. I'm just not good implementing it in code. Okay, so let's go down here. We are going to say the following. Let's do void. And just for now, we're going to say depth first search, just to get kind of the skeleton out there. And what do we need to read in? We need to read in, I suppose, node. And what do I want to do? We want node star, and we'll give it root. I suppose we should always give it root. Okay, now in the depth first search, we're going to have to do something with the objects, but that's okay. We'll kind of hit that as we hit it. For now, I just want to have the very basic depth first search written, and then we'll kind of go from there. It's okay. You can move and split an atom in half and create a nuke. No, that's not quite right, but you're getting there. So let's do this, A, there. Okay, so the depth first search isn't very difficult. Since we already have our 8 subsections, all we have to do is go through and just recursively go through each of these subsections. Again, we're just going to very quickly write out a skeleton here, and we will do what we need to do later. In the end, the depth first search is essential to doing our force integration, which sounds weird, but again, it's definitely useful. Time travel, again, is not physically possible, but it's pretty cool. So depth first search, what do we need to do? Well, we're going to have to go through all of the different elements here. So we have 8 different children, right? So we just go through all the children. So basically what we'll say is if we have children, we go through all the children. So we'll say if, and I suppose we just say root. Oh, this is where I had some issues last time. Let's read in node current. And let me go up to the top here. I know you have an NDA, so wink at the camera if true. I actually don't have an NDA. All my stuff is open source, so feel free to steal it all. I don't care. G down here. Sci-fi much, man? To be totally and completely honest, a lot of the sci-fi, like people who were interested in sci-fi become physicists, My old boss, man, he is the biggest Star Trek nerd. I mean, like, all of his computers were named after planets. It was just, it's kind of nice in a way. You need to add children null pointer to both the node constructors. Yes, you're right. Let me go up here. Let me just do this real quick. Just so we have that there. Okay, go to the top. Node, what do we have here? STD array, children, what do we want? Let's do node here. And let's do particle center of mass. Okay. Children. This actually might be a little bit complex. We'll just see what happens. Null pointer. Here. And let's go here and do children. Null pointer. I still don't understand after all those years, what do you actually achieve with actual physics? I don't know what you mean, Frank. Lauren. No, you need to use, what did I do? 1 second. Oh, I put it in the wrong spot both times. 1 second. You need to use the following. What did you say? Children null pointer. Oh, yeah, because we have 8. Yep, 1 second. Okay. So I'm not sure exactly what you mean, Frank, when you say you don't understand what you achieve with actual physics. So what I'm going to answer is something that's a little bit, how do I put this? It's a little bit vague, but I think it's worth being said. So let me go here and put all the children directly under parent, so when they're initialized, we don't get the warning. So physics is one of those things that is intrinsically interesting. Let me see, error. Oh, of course, that's going to be an error. I didn't even try. It's one of those things that will, let me see, if current pointing to children. Yeah, let's do this. And then we'll pop this down there. Good. Yeah, it's a situation where, but actually this is a good point. Like, for example, when I went home to Alabama the other month, I suppose. I guess it's been a while. But my grandparents were asking, like, what is the point in research in general? You know, they were asking why even waste your time on that type of thing? And for me in particular, I'm so far removed from engineering. Like, I do, you know, theoretical physics. I'm not as far removed as some people, right? A lot of people are way more removed than I am. I'm somewhere closer to the experimental side, which is somewhere closer to the, how do I put this? The engineering side. So we're almost getting to the point where it's somewhat useful to the consumer. But a lot of people just think that if what you're doing is not directly applicable to the market economy, it's not useful. But here, you know, we see clear advances in, you know, the standard of living everywhere when you have good research. You know, it increases the education, it increases, you know, the ability, like the potential for engineering applications later. It's something that we need, you know, it's just something people don't necessarily want to pay for. So it's kind of one of those things that I've been thinking about a lot, and I don't know the solution, because in the US in particular, people are currently like really trying to, you know, cut down on funding in some places. Just because they don't understand the utility of it. So I don't mean to kind of go on that topic too long, but I just want to point out it is something that a lot of people think about. And a lot of people think that physics is not useful, but in my opinion, obviously as a physicist, it's essential to understanding the world around us and bettering a lot of different aspects of life. Okay, so if we have children, we're going to do this. 4. What are we going to say? We're going to say 4, auto, why not, child, chili. I did the same thing yesterday. In current, pointing to children. Bam. Then we're going to say, depth for a search. And we're going to say child. Is it not valid? Let me see. Why is it not valid? Oh, yeah, I guess you're right. So how about we do it the other way around? Wait, the for loop alone would work? I feel like we need more than just a for loop. Let me see here. 4x. Here and there. Good. For auto child. If it doesn't get you money, it doesn't benefit the US. Wait. 1 second. If it doesn't get you money, it doesn't benefit the US. The US's capitalistic society. I mean, it gets me money as the researcher. You get money, and everyone else gets money eventually. Yeah. If you do at the beginning of the function, do if current. Wait. At the beginning of the function. Oh, you want to do this. But I'm not returning anything. It's a void. If current. Let's see. What do I want? I guess just break. Yeah. So on that topic, how do you get money? You're well paid since you have a 970. No, I just save all my money. I mean, as a PhD student, you typically get some sort of stipend, right? So my stipend here is reasonable enough. So if I write return, this isn't going to break. Go here, make. Okay, let me see what happens. So we have all the, I guess we have the root node being generated in main, right? So let's go up to main. Let's just very quickly run this. It shouldn't do so much. So let me also output, I guess with every node, let's output something just to make sure that we're going through things. So let's output its current position. So we're going to say std cout, and let's just output the position. So we're going to say current.p.x, new tab, current.p.y, and I think I'm going to have to put arrows here. Sorry about that. And you live only on that? I thought in the US you could invest a fortune. You had to invest a fortune to go into college? I don't know how true that is, honestly. To be totally completely honest, I don't really know very many people at all who had to pay, an arm and a leg to go to college. There are some people, but it's not common, I don't think. P.Z. Truth be told, most people that I know had some sort of scholarship to go to college, and honestly, most of the people in the physics department had a full ride scholarship, so they had everything they needed paid for. So we have root here, divide octree, good. So now what I want to do is depth first search. So depth first search, and we're going to do root. Okay. See what happens if we write that. Go here to make. Good. So we have positions for all the different boxes, which seems fine to me. So let's see what we have. Let me go here, right? Like with particle physics, quantum particle physics, you discover magnetic resonance and help humanity with MRI scanning, for example. Yeah, it's nearly impossible, especially in hardcore physics, to see where what you're doing will come into play later. Like it's hard to see. For example, quantum information, for example, people typically know, okay, sometime in the future people are going to make a quantum computer, which is fine. But other places it's not so obvious. Okay. So let me see what we have here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 boxes. That's probably correct. Sure, I'd go with that. I'm not really sure what all these positions are. So we have something very simple here for our depth first search algorithm. Just kind of going through, making sure we can search through all the things. That's because they get the money and only pay interest in the beginning. After completing the degree, they have to pay the interest plus the parcels of the loan. Back to the conversation about, sorry, I've been going back and forth. Yeah, so again, in the US, people do pay a lot for college. I'm not saying they don't. But what I am saying is that the people I know, most of the people I know that I met at my old university had some sort of scholarship to help them pay for it. So it was kind of one of those things that only people who were going to like medical school or law school really had to pay that much. That said, there are currently scams all around and stuff like that, and I'm sure people get caught by that all the time. And if you want to go to a top tier institution, you're probably going to have some trouble if you don't have some sort of financial aid. Again, for me, I had a full ride, so I didn't have to pay anything. So I'm not the best person to talk about this. I know a lot of people go into the military for a while, and then after going to the military, they get full college tuition paid for. Different things like that. There are ways for you to get your college paid for. So it's not like it's impossible. I just find it, I just think that I'm not the best person to talk about this. Okay, so let's do depth first search here. So one thing that's kind of weird about the depth first search thing, we have a lot of numbers here. I gotta go a little early today, I'm really tired. That's okay, Gustron, thanks so much for coming in. You, of course, were a big help as always. I'll take a look at your version of the code, if not tonight, this weekend, and we'll go from there. So, thanks again for coming in, and have a good night. Okay. Yeah, see ya, Gustron. So let's see, Frank, yes, most research that is in that is biophysics, like gold nanoparticle as agents. Oh yeah, actually there's some really cool stuff there. Okay. So what are we going to do next? Let's go through and take a look here. I'm not liking something here. This first 000 is odd to me. Okay. Then, going through all these guys... Oh, the first 000 is probably fine. That's the root node. Okay, that's fine. The root node is exactly there. Okay. So the next one's at -25, -25, -25, 0.25. Sorry about that. Okay, so these guys all look okay. Sure. Then it's split up. Let me see. How many boxes are we going to have? Let's think about this. We have 10 particles. And let's just go up here and count what we have. So let's see. We have 1. Oh, these are all the particle locations. Good. Okay, what's this 2 over here? I'm not sure what that 2 is over there, actually. I have no idea. 2, 3, 2, 2, 3. I don't remember. Let's go and check that out. Okay, so where are we outputting this? We are outputting it in... I should just go to see out. Here it is, here it is. So the last one is the mass. Okay, the mass is fine. But why is it 2? Not sure. Shouldn't be 2. Should be 1. Right, because if we found a particle... Oh, you know what I probably did? Let me see here. Child, we've already initialized them all with some sort of mass, right? Then we add 1. Yep. Yep, yep. Good. I thought you left, Gustron. Okay, okay, so these are 1 over what they should be. What we can probably do... Let me see. Center mass. 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 Why would it be 2? Particle.mass. Com.particle. Plus equals P. It's okay. This is an off by 1 error. We can figure that one out. What we're going to have to do from here is... I wouldn't doubt it. He probably just sleep talks physics and code. Okay. So the issue here is that we're adding a particle mass every time. So the center of mass should not be initialized with... It should be initialized with a weight of 0. So let's see. What do we need to do here then? We need to initialize center mass with a weight of 0. That should be good. So whenever we make the... what are we talking about here? Whenever we make a node... Let's go here. Where is our node? We need to initialize it with a center mass of 0. So where are we? We're here, node here. And let's do it. So we're going to say, pop it down here. We're going to say center mass of 0. We're going to do the same thing down here. Center mass 0. Let's go over here. Let's make it one more time. Oh, I'm doing this wrong. 1 second. Let me think here. Box length 1.0. Center mass P. Vector P, box length 1.0. Oh, interesting. No mention call for particle int. Do I have to do 0.0? 1 second. Right here, make this. No mention call for particle double. That's because center mass is a particle. I see. Obviously, what I need to do is give it a position too. So let's go here and let's give it also a position because I don't know why I didn't to begin with. So we'll say vec 0. Let's go here, check that one. Vec 0. like that. That one made, good. And now we have the appropriate particle number. All right, let me bring the center mass down to the bottom just so that we have everything set. I don't know what I was thinking there. I appreciate you guys not being jerks about that one. Okay, so let's see what we have here. So we have one box with 3 in it, apparently. And then, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay. So how is this being split up? And we split it up first into 4. So that's 8. 8, actually. We split it up first into 8, right? And then we split the further boxes into 8. So how many do we have here? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay, this is fair. As long as it's a multiple of 8, I'm going to assume that we have something here, which is good. Now, what we have to do next is worry about visualization. So let's go up here to the top. I'm going to say we've done the depth first search, but I'm going to leave the note in there because I need to add something else and say this is for force integration later. Good. Now we're going to say force integration. Oh, the very next one. Let's do visualization first. We're going to do the visualization with NuPlot. Reason being, I found some interesting code to visualize squares in NuPlot. Yep, let's do it. Okay, we're going to have to do something. We're going to have to include, I guess it's fstream. Yep, for file input and output. I guess it stands for file stream. Obviously, every time I write this, I think I remember that, but then I forget. So, depth of search for force integration later. Good. Visualization is what we're moving on to now. So, what do I need to do? I need to create a function to draw or to output the tree. So, let's do function to output vertex positions of cube. Plural. So what do we need? We need to, let me think here. We need to do the following. So we'll say void, because I don't think we need that much here. And what we're going to have to do is we're going to have to read in, let's do octree output. Let's do this. We'll call it that. We're going to have to read in node current. This is probably going to have to be recursive. And then we're going to have to read in the file that we're writing out to. Or, we should probably read in the file we're writing out to. So let me think. We've done this before. What is it? Fstream, I suppose? That's wrong. It's probably offstream or something like that. Dagnabbit, I always forget. So let me go here. Let me go into VI. Let me do something in the archives. I'm sure I have something in the archives, right? Then we'll go into MD, daemon, daemon.cpp. Let's look for fstream. There it is there, obviously. The BlackBerry Tea. The topics on this stream are fantastic. Optics visualizations to space trees. You know, quite frankly, I just pick whatever's interesting to me at the time and whatever I have enough time to go into. The optics visualizations was actually super fun for me. Like, I really enjoyed doing it, but I understand if it's not everyone's thing. What we're doing now is we're doing a tree to organize space so that we can do space simulations. Yeah, that's it. Okay, so let's go here. It should be std upstream. Sorry about that. There we go. But I had the upstream right. And ampersand. Good, so that's going to work. Now, let's go down to where we define everything. So I think we do it in main here. Because why not? So let's go down here and define it. Yeah, let's do it. So we'll defining. Oh gosh, we're not going to be able to finish on time. How do I do this? Defining file for output. Okay, so we're going to go down here and we're going to say std upstream. And guys, I apologize. I always have to look this up. Output. No matter what I do, I always have to look this up. So now we're going to say cube.dat, I guess. Out.dat. I always call it out.dat. Let's do it. std upstream out. Okay, that seems good to me. What else do we need here? Upstream, out. Is that all we need? Let me see where we put the output. Here we go there. Next, output's here. Output close. Dot close. Might be all we need. Semicolon there, write this. Let's see, where's the next output? Next. Output all the data. Output here, output there. Output. Yeah, that's it. Good. We're getting there. Okay, so what do we need to do next? Octree output. We need to write this function. Gosh, how far are we going to be able to get in 10 minutes? I have no idea. Let's go. Worst comes to worst, we just keep working on it next time. Okay, so this actually is not trivial what we need to do. Let me show you the new plot code. Right here. Go over here, right quit. Let me just cd into, I believe it's going to be tests. Yeah, there we go. ls. I've got a whole bunch of weird tests here. Don't worry about any of that. What I want to look at is a new plot code. There it is, cubeplot.gp. So let me go into vi cubeplot.gp. Okay, let me just uncomment all this, right quit. Let me run new plot cubeplot.gp minus. Okay, so here's the cube in new plot. We're going to be using something like this for our visualization, just for now, just to kind of get something out there. Control D. For now, we don't need to do anything special with it. So I want it to kind of look something like this. New plot. There we go. We have our cube. Okay. In order to get this cube, we need to output data like so. Cube.text. There we are. Okay. So we need to output all the vertices like so. So here's what they did. They drew 0, 0, 0, 0, 1, 0, 0, 1, 1, 0, 1, 0, 0, 0, 0. So they basically drew the bottom square. Then they drew the top square, right? Then what they're doing next is, let's see, 0, 0, 0, 1, 0, 0. So then they draw one side square and then another side square. So they're drawing 4 different squares. We need to do something very similar here, where we need to output all of the vertices of our cube in such a way that we can later plot it pretty easily, right? So we're gonna have to output something that looks like this. This is not gonna be trivial, so we have to think about what we need to actually output. Good. So let's go down here, and we're going to assume outputting current node vertices. And then what we do is we go down here and we do exactly what we did before with the depth first search, and we go through all the children. So we'll do this, grab that, paste it down there. I failed to put an I at the start here, my bad. And what do I need to do? Let's go here, grab this, remove this stdc out, and basically put it down there. And now we're gonna say, do what we need to do. And then we're basically going to go through and do octree output for all the children. And it's just going to be a recursive way in which we go through and output all the data. So octree output. And guys, if you have any questions or comments, anything like that, we've had a pretty active discussion today. So feel free to continue talking. I'm obviously not going to shut anyone up for any reason whatsoever. Okay. What vertices do we need to output? Well, let's start. So I guess we'll do bottom cube first. 1 second, first. So we're gonna say bottom square first. Okay. So obviously we have an XYZ location, right? So let's do this. We're going to say output. I guess it's this one. And we'll say, for the X position, Z position is the one that's going to be weird. Oh man, this isn't trivial at all, is it? Do I have to output all? How many are we going to have in the end? 5, 10? Yeah, actually, this isn't, we might have to do all 20 by hand. Is there another way to do this? Huh. Let me think. Surely there's a better way to do this. Let me see. What did we do up here? So up here, what did we do? We gave them all a particular position. Okay. Something similar to what we had before. Lauren wrote this one. Oh, I should probably write that. Did I not write that? Let's go down here. This was written by Lauren. 1 second. Lawrence BL. Good. Okay. Write this, go down to the bottom. Okay, so now let's see if we can figure this guy out. We have to be able to draw our cube, right? So we have to give it the appropriate positions in order to do the drawing. This is hard. We could specify all 20. I hate writing that much code. You know, here's the thing about programming, right? Everyone says programmers are lazy, but like they spend their entire time, like all day, working to write less code, if that makes sense. Like, they spend their whole day working on ways to be lazy. So it's not really being lazy. You're just finding intuitive ways, or not intuitive ways, you're finding interesting ways to skirt around your work, and your work is finding those interesting ways to do that. Okay. So if we're going to do the bottom square first, that means Z is always going to be at the bottom here. And we could say, we could have a couple for loops. No, that's not going to work. Shoot. Okay. Let me go over here and draw the problem. New page before. Here's what we got. So we have a square, a cube, let's say. And here's one of the big problems. Here is my first square. Here's my second square. Here's some lines that go from one to the other. Pretend they're lines. Okay. So we have a total of, let's see, 1, 2, 3, 4, 5, 6, 7, 8 vertices. There is no way to draw a cube in one stroke. It's not possible. Now, maybe you guys can find a way, but based on my understanding of mathematics, and my several attempts last night when I failed to invoke my understanding of mathematics, it's not possible to draw a cube in one stroke. So, what we need to do is we need to draw a whole bunch of smaller cubes. So we'll draw this cube first, for example. Oh gosh. Let me try that again. Maybe this cube first. There we go. Then maybe this cube next. 1 second. Then we draw this side cube. Okay, that was meant to be a straight line. This side cube here. And then this side cube over here. Okay? And that will provide for us... Man, why does it sometimes correct and sometimes doesn't? That will provide for us our cube. So we have to draw 4 different cubes. Now, the question is, how do we do this in a way that we don't have to actually draw out all... What will end up being 1, 2, 3, 4. Something like that. I'll try something in a similar vein as the code before tomorrow. Problem is that we need vertices in order, and all 3 times in a different pattern. Yeah, so that's kind of what I'm thinking. And Lauren, you don't have to worry about it. I'll be thinking about it tonight too, and we'll implement it tomorrow. So the first thing we'll do tomorrow is a visualization, which again, honestly, even though we spent a good bit of time today just talking, we still got a good bit done. I'm gonna have to leave this part here though. Unfortunately, I'm just not quite sure how to progress. So let me go ahead and quit here, cd into the appropriate directory, which will be Simuleos, and of course, Barnes Hut. Now we're going to do a quick make just to make sure we don't have any errors. Of course we do. Octree output, too few arguments, of course. So let's do this, and let's grab file. Now let's try making that, just to make sure it still makes. Okay, everything still makes. Up till now, I think we have our octree actually drawn. Let me go up here to the notes and see what we fixed. In terms of what we've actually done so far, we hit those first two notes. We need a separate particle struct to hold vector, mass, and radius. We set everything pretty much now, except for one thing. Let me make that. Okay, now everything's set. We have a new particle struct to hold our vector, our mass, our radius. We have implemented the depth first search. Again, it was super easy, got it done. We're going to be using that throughout, but probably not that function in particular. Then what else do we need? Force integration. That's something that we need to add in, but for tomorrow we'll do visualization, and then we'll kind of sort of think about how we want to do force integration. What I want you guys to tell me, and you guys don't have to tell me now, maybe send me a message later or whenever you feel like, should we do 3D visualization with Blender, which means outputting a large data file and having Blender do the visualization, or should we find a way to plug our simulation directly in? Does that make sense? So do some sort of 3D visualizer like the visualization toolkit or something like that, so that we can we don't have to have a data file. We never have to output to a data file. We just immediately in the C++ code do the visualization from there. We could do OpenGL, we could do VTK. I haven't quite decided, but this is a pretty simple 3D visualization to do, right? It's just a bunch of particles and stuff like that. Real-time visualization is worth gold almost always. Yeah, maybe. I've just never really done real-time visualization before. So we'll see how far we need to get. Anyway, guys, for now, I think I'm not going to commit this code to GitHub because there's still a few things I need to take a look at, specifically with Gus Torn's code, and I need to fix a couple of things up. But we did make significant progress today, and I'm quite happy with how far we've gotten. Happy, little rat? Yeah, I agree with you, Lauren. I've never learned OpenGL, and it's one of those things that I see a whole bunch of people learning, and they say it's good. Faster you get iteration cycles for changes, faster you can develop something. Yeah, I agree with you there. Yeah, I agree. So we'll see. I think I'd like to do OpenGL or something like that, but at the same time, I almost feel like it's overkill in a way. I also really want to learn Vulkan. Like, I really want to learn Vulkan. I don't know why, it's just something that's on my mind. Anyway, we will talk about that later, probably tomorrow when we're doing the visualization with just Nuplot, just to make sure that everything's working well for the Octree code. And then we'll go from there. So at this point, guys, I'd like to thank you so much for watching. Have a great day, night, afternoon, morning, evening, whatever time it happens to be your time. And it'd be good to take your time to learn simple visualization. Just do more standard old OpenGL. Fair enough. Yeah. I've got a feeling that, you know, I don't know. We'll see. Anyway, guys, thanks so much again for watching, and I'll see you next time. Bye, guys.